the first dot here, between P and S, we can use our formula, which is going to be F equals K Q1 Q2 over R squared, where Q1 is now going to be S with a charge of plus 8 microcoulomb. So if we use our formula, we're going to say F is going to be equal to K, which is 9 times 10 to the power 9. We multiply that with the charge on S. Remember, we leave out the sign just like we did previously. 8 times 10 to the power negative 6. And the charge on P is negative 4 microcoulomb, so that's 4 times 10 to the power negative 6. We divide that by the distance between the two squared, but remember it must be in meters. So it's going to be 30 millimeters. We convert this 30 times 10 to the power negative 3. And very important here that you remember to square it. So if we go and we calculate this answer, we'll see that the value of the force between P and S is going to give us 320 Newton. And remember, because P is negative and S is positive, we know that the force that S experiences will be an attractive force, and therefore this is going to be upwards. If we look at the electrostatic force between S and R, we can say that the electrostatic force, remember, we always have to give our formula F equals K Q1 Q2 over R squared, just as we practiced yesterday. If we substitute our values, it's going to be 9 times 10 to the power 9. That's the constant value of K. We multiply it with the charges, 8 times 10 to the power negative 6. And we multiply that with 6 times 10 to the power negative 6. And now substituted the value for R into this formula. And the distance between the two, 60 millimeters, which we need to convert to meters. And that's going to be 60 times 10 to the power negative 3 squared. If you go and you calculate this, your answer is going to be 120 Newton. And because the one charge is positive and the other one negative, the force that S experiences is going to attract it to R, which means this is now 120 Newton to the left. What's important for you to remember now is that when we have these two values, we now need to go and look at S as a free body diagram. So if we go and we draw point S, we can say that the 320 Newton upwards is this force over here, 320 Newton upwards, and we know that we've got 120 Newton left. So if we go and we draw these two, remember there's more than one way in which we can draw it. I'm going to use the head to tail method. So I'm going to start where my first vector ended, and I'm going to do the 120 Newton left. So what we see now is that when we want to calculate our F net, or our resultant electrostatic force, we connect the beginning of our first vector with the end of our last vector. And now we see that this hypotenuse is going to be F net. When we want to solve F net, we can use the Pythagoras Theorem. And if you use the Pythagoras Theorem, we can say that the F net force is going to be Fp on S, which is the 320 Newton squared, plus Fr on S, which is going to be the 120 Newton squared. And remember, when we do this, we have to find the square root. So when you calculate F net, it will give you a value of 341.76 Newton. You can, of course, then also go and use sin, cos, or tan to go and calculate the angle. If you use tan theta, it's going to be Fp on S divided by Fr on S, which will give you 2.67. And if you go and calculate that angle using your calculator, it's going to give you 69.44 degrees. And that's basically how we calculate electrostatic forces in 2 dimensions here. Do you have any questions?